let's say, other basic functions. We only have so far y equals x squared. And as much fun as it is to just look at one, it's probably a good idea to have a couple, have some variety, practice these transformations and review them as well. So we will expand on this and look at higher powers of x. So the next one up will be x cubed. Now that, as the basic graph, you can make a table of values. If you have enough, you'll see it is flat here at 0, just like the parabola, a little steeper, increasing a little faster, flat, and turning the other way. So just make sure, many people, let me show you here, if I happen to ask this on a test, many people do this curve through the origin at an angle. That is not right. You need to be flat through there. So just watch out for that, and then it has sort of the same feel as a parabola, but when you put them on top of each other, this x cubed graph is a little bit faster growing. Then we also have y equals x to the power of 4. Now, because the previous one was x cubed, any negative x value that you put in is going to have a negative y value, and you get this kind of symmetry. But when you're back to x to the 4, then everything is positive again. It's a little fatter at the bottom, more of a U shape if you compare it to a parabola, but really you can think of a very similar shape. And in fact, if you were to draw y equals x to the 6, x to the 8, x to the 10, they're all a very similar shape. And on this side, y equals x to the power of 5, x to the 7, x to the 9, and so on, all have a similar shape to the x cubed graph. And as a result, we don't really bother with the higher powers when they do have the same shape, and there's no real benefit in this transformation topic to worry about all of them. So we'll include these two as more basic functions on top of the one we already have. So as we go, we'll add more basic functions, and then of course we can do a transformation question with those functions as well. I'm not sure if I have in problem 1.9, whoops, something fell out. Problem 1.9, I have other functions that we're looking to apply our transformations on. So let's do some of it. I'm not going to do the full one. Let's maybe do, I don't know, number 5 might be nice. Now that problem is asking us to state the sequence of transformations on this function. So we're given y equal to negative bracket x plus 2, everything cubed plus 1. The question as written there asks for the sequence of transformations and then to use that to graph that function. I'm going to leave the graphing to you and just do the sequence. Just in the interest of saving time, and we've done the graphing already. So I'm going to start with my obvious basic function. Which transformation would you like to do next? I really have only one safety requirement for me. And that is to leave the transformation that results in a vertical shift to the end. Because I don't want to shift it up or down and then have to reflect it and stretch it. It could create silly mistakes. But past that, I can choose whatever I want to do. I like to take care of any possible numbers first. So I will change the function by multiplying the right-hand side by a negative, and that's going to be a vertical reflection. Then I'm going to replace the x with an x plus 2. That's not V3. That will result graphically in a horizontal shift, and then I'll just go down here. Lastly, the one I want to leave until the end is adding 1 to the right-hand side, and that will correspond to a vertical shift. Now, if you're not super comfortable with doing the graph transformations that fit that sequence, then take the time and practice. But since we have done that already, I'm going to leave that for now. Any questions on making the sequence of transformations? What to watch out for, what you can sort of choose yourself. This is very much a midterm 1 question, so you won't waste your time if you practice this. And there are other problems. There's an x to the 4 basic function. And of course, if I simplify these, I will get an x cubed term, I will get an x squared, an x term, and so on. So these functions simplify, we'll say, to the kind of functions that we call polynomials. And they're generally going to look like, I'm going to call them a function. Could be y equal to as well. Let's pick a highest power of x, and we're going to call it the degree. Now, in general, it might be a 3, it might be a quadratic, 2, could be to the 4, could be anything. That's going to be the highest power of x, and I'm going to have some number in front that I'll call a sub n. Then, the power of x could a term with one lower power of x could feature, and it has a different number in front of it. And all the way down, maybe an x squared term, maybe an x term, and then maybe just a constant term. So these basic functions, in that nice form, I can use transformations. And we saw that with the quadratic function, a degree 2 polynomial. If I have it in this simplified or general form, it can be a little bit more complicated to see the transformations. But still, I'm looking at this family of functions. This last one here, just a number, is called the constant term. This is called the leading term. This little a in front is called the leading coefficient. And those are all the words I need to know. And again, I'm not mentioning words if you don't need to know it. There are many things you don't need to know. I don't really care for this course to factor higher degree polynomials, rational root theorem, none of that. I assume we've done all those things. We're not going to do a lot of those precalculus things, but some of these words and some of the key parts to this kind of polynomial is important for the next section. Yes?
What is the state of the constant term?
A 0.
Okay.
Because I let the subscript fit or match the power of x, and technically that is a 0 power of x, the term that has no x. in it. But for a specific example, this is just sort of a template form. We will usually have specific examples. Any other questions? So we'll do stuff with polynomials, but more, not just the higher level stuff, more behavioral stuff. What does the graph look like? What is its key features? Not necessarily the factoring and stuff like that a lot of precalculus spent a lot of time on. Not that those things aren't important, it's just not our focus. So there's one more interesting basic function that I want to include, and we'll work with those for a while. One more basic function, and it's going to be the square root function. A little bit different in that it's not defined for all x values. Not defined for negative x values. I can't find a real number answer when I plug in a negative number in my square root. Whereas all the polynomials, they will give me an answer for any input I choose. They're very nice in that sense. This one is not. So when x equals 0, the answer, the y value is 0, and then it goes up, sort of like a sideways parabola, but only half of it. Whoops, let me do it again. So it's nice and vertical in the center, and then it's like, yeah, pretty much like a sideways parabola. Well, it's exactly a sideways parabola. Just half of it, though. Just half of it. We're only looking at the function is defined as the positive square root. So I get something a little bit more interesting, not complicated, just more interesting in that it's not defined for every x value, and it's a little bit of a different shape. But of course, we have this basic function. We can do a transformation problem on it. Let me do. Is there something on this side? No, not really. Let's do number 4. So there I'm given y equal to a half square root of 2 minus x minus 1. The minus 1 is outside the square root. All right, so it's in a nice form where I can make my sequence of transformations. Let's have a look. So let's do this in a little bit more detail. I start with my basic one, and I will make some space over here. It doesn't have to be big because this is just me keeping track of how the graph changes. Then I'm going to go, I'm going to fit in 3. I'm going to do 3 in a row here. I think I can. Then I'm going to do 1. What is the first one, or the next transformation you would like to do? Yeah, pick one. We've done a few of these now, but I remember my safety rule. As long as I leave that minus 1 until the end, it's all good. So maybe I want to do the half. I like to just get that half done. So then I'm going to make space for my graph here. I'm just sort of planning this out. And I'll fill in the graphs in a second, making sure I have the space. What do we do next? Yeah, I'm going to leave the minus 1. So the only thing left is the 2 minus x. It only looks like there are 3 things here, right? 2 minus x, make some space for my planning. My graphs will come. My graphs will come. like to label my axes. Okay, and then I still have to do the minus 1. So that'll be my last one, so I might as well center it over here. 1/2 root 2 minus x minus 1. And I know that's a pretty easy vertical shift. I just have to leave it until the end to avoid unnecessary complications. Okay, so let's zoom out a little bit. So I've sort of planned my sequence of transformations, and it might, in your answer, might look something like that. So my basic graph, I remember what that looks like. I need to just memorize that it goes up nice and vertical here at 0, and that's the important point, 0, 0. Then, yeah, I multiply the whole right-hand side by 1/2, so everything's a little squished vertically. I'm not going to exaggerate that. Maybe I'll keep track of a point 1, 1. Square root of 1 is 1. And by doing that, I don't have to zoom in on that shape for now. I don't have to squish this actually by 1/2. I can focus on a nice comfortable shape and indicate that, oh, it might not look like it, but the new y value of that point is now 1/2. So by showing how a convenient reference point has changed, I don't have to compromise my nice smooth shape, which is a little bit wider than it is in reality. But just like for the parabola, if I draw a narrow parabola, it's really hard to do future transformations on it. So it's a matter of convenience. If I didn't show a point changing, well then, it's not very believable that I understand what the graphical transformation is, but I showed that the point that was at a y value of 1 is now a y value of 1/2. So I, in that way, show that I knew what to do with the graph. What happens next? What happens to the graph next? This is very much a possible midterm question. What would you do? You've made your chain of transformations. Now I want to match the graph to eventually give me my graph in the end. What do I do to the graph? Well, what did I do to the function? Because the function changed first, and the graph is a result, or the change in the graph is a result of that function. What did I do to the function to go from that middle one to the right one? First of all, did I do something to the whole right-hand side, or did I do a replacement? Those are only two things we did. Did I take the right-hand side, the middle, the 1/2 root x, and do something multiplying or adding or subtracting or something to the whole right-hand side? No, definitely not. Which means my only other option is a replacement of x with something else. Is that what I did? Yes. It's my only other option. Those are the two transformations. Now, if you remember your list of transformations, the whole point of making, where's my, there it is. Let's make a new page. The whole point of making that list of transformations was to isolate each one and make it as simple as possible. What was the list of transformations? I'm not saying you can come up with some other transformation. Sure, there are more complicated ones. But the goal of this list was to make it as simple as possible. You remember the list? We have to remember the list because we need to fall back on that list. One was take a function, and what was the first one? I can't remember the order which we did this. Maybe the vertical stretch and compress. So look familiar? What was the second one we mentioned in that list? I don't remember the order which we did. Maybe multiplying the right-hand side with a -1. That was vertical reflection, flipping it vertically. Let's just do all the vertical ones. I know I leave this one to the end, but might as well write it now. Plus, we call it Q, I think. That's the vertical reflection. So those are all straightforward. The replacement one was what? So these were all doing something to the right-hand side, and that resulted in a vertical transformation.
That was the horizontal shift.
The last one was replacement of x, and that results in a horizontal transformation. Whoop, that was not very well written. Transformation. What did I replace x by? The reason we did it, because now we're using it. Look back at your notes, do whatever you need to do. What did we replace x by? What was in the bracket? In this empty one? X minus some number. It depends what it is in a specific example. It could be a 1, could be whatever. And then that replacement corresponds to a horizontal transformation. But there's another one. There's another one. That's also a replacement. That's not a big deal in the polynomial basic functions, but the square root is a little different. Just like here, I've isolated the positive vertical stretch with multiplying by a negative number. I separate those two because graphically the effect on the graph isn't the same. Here as well, if I replace x with a negative x, the effect on the graph isn't something I've covered before. If I just isolate that, for example, and take square root of x to square root of negative x, what happens to the graph? I know it's not our actual question we're doing, but we need it. And it's not a transformation that I really cared for in the polynomial case because it wasn't necessary. In the polynomial case, I could always get rid of a number in front, but the square root is a little different. So I have my basic function, square root function, that I now notice it looks something like this, like a sideways parabola, starting horizontal at 0. If I keep tabs on a reference point here, maybe 1, 1 is a nice one. And see where that now goes. First of all, if x equals 0, I still have 0 inside the square root, so that bottom key point is still in the same position. But previously, in the basic square root function, to get a y value of 1, x had to be 1. Now to get a y value of 1, x will have to be what? It has to be -1, so that a negative, excuse me, a -1 gives me a 1 inside the square root, thereby giving me y equal to 1. So that point now sits on the other side, and so will every other point. So this side's a little bit tricky for me to draw without looking. That's not bad. So when x is -1, I'll get a y value of 1. Because of that minus that is handled first before I apply the square root in the calculation. Does that make sense? I know, everyone's sleepy. It's only 9 o'clock. Snow makes one sleepy. So tomorrow we're going to be completely. Just bring a pillow. Bring a pillow tomorrow. Just play it safe. So this is not a this is not a transformation graphically that's in our list, because the top one there, replacing x with x minus plus or minus a number, is horizontally shifting the graph. That's not this one. This is reflecting it horizontally. So it's a new transformation. And I want to isolate these different things happening to the graph. So this I'll just call a horizontal reflection. And because I've replaced x with something, the effect on the graph is horizontal. But I replaced it with something else, so the graphical effect between those two is not the same. It's not the same. So now, what if I took this and now I replace x from the previous one, I take it out, and the replacement is only that. You take out the x, you put in, let's say, x minus 1. So what I want to do here is replace x with x minus 1. This one, I want to do this function transformation. Is that what I get? Did I do it right? Is that the function that I get if from the top one I replace x with x minus 1? Let's suppose that's what I want to do. Is that the function that does that? Why not? You don't like it? What's wrong with it?
The whole function is has negative sign, so it will be manifest.
Whatever I take out, the negative is applying to that. So I better put some brackets there. That is a replacement. And if I do that, we've seen before, that is a horizontal shift. I'll squeeze it in over here. I think I can squeeze it in. Sure. So, because I've done the replacement, the graph corresponding to this bottom function is the previous one shifted to the right by 1. So it'll sit somewhere over here. If I can be nice and smooth in my curve, and that's going to be a 1 and a 1 there. If I simplify this, just to see what it looks like, what could I also write inside the square root? Or it's a simplified version without the brackets. I didn't say it was hard. I just want you to say it, do it, look at it, instead of copying down what I say. If you simplify that function inside the square root, what would you get? 1 minus x. So that tells us that if I see something minus x inside, there are really two transformations hiding, pretending to be one. The only way to get that is to bring in a negative in front of the x, and the only way to do that is with a replacement of x with negative x. Then to get that 1, I'm really going to have to do this kind of replacement. It's not something that I want to do for safety reasons in one go, because technically there are two different things happening to the graph in order to get to that last result. There is a reflection and a shift happening. And if I try and do that in one go, nothing good is going to happen. The whole point of this list is to isolate the transformations to make them easier. But that's now exactly what I have here. I have exactly this kind of thing. Which means, what was this transformation? Is that a single transformation? No, because I'm not allowed to replace x. Well, it's not like I'm not allowed. Based on our list, to make things simple. That list does not cover replacing x with something minus x, because there are multiple transformations happening in there. And to be safe, I should probably update this to first take care of the negative x. And that means that before I can go to the end, I should do my full replacement first. But looking at it this way doesn't show me exactly. Okay, let me just finish this. This is an easy one. It takes the previous graph and reflects it horizontally. So let's just do that. I'm trying to make it the same shape, but I think I'm going to be a little wobbly. That's okay. So now my negative 1/1/2 is the point that I was keeping track of. Now, how do I shift this? I want to guess. I can rewrite this inside the square root by taking out a minus and making it look like this one. Here I saw exactly it was replacing x with x minus 1. They're trying to hide it from me. So what is it going to be in this case? It's going to be x minus 2. So it's going to be 1/2 replacing x with x minus 2 means that I'm shifting the graph, which I need to make space for over here. I'm shifting it how? How am I shifting it? 2 to the right. 2 to the right. And I only feel better about that, or more confident, when I see it in this form. Here it seems like, oh, the 2 is positive, so I should shift it to the left? No, it's shuffled around. And I need to see them in isolation to not make a mistake. So I'm going to shift this to the right. Ooh, that is not very good. Let's try again. Maybe if I turn my hand, no, that's bad again. Just have to commit to my parabola shape and let it be what it is. So that's going to be a 2, and I'm going to let go of my reference point because I don't really need it. Then I'll go and subtract 1, shifting this down a little bit to here. Oops, nope, back that up. I'm going to have to zoom in to make an easier drawing, I think. Like that. Now this guy I can keep track of. It's going to sit at -1, 2. I always want to indicate the y-intercept, but that is easy to find. I don't need to do it on the way with every graph. All I need to do is plug in 0 for x and find out what it is. Now it's not the nicest number, but we can calculate it. 1/2 times square root of 2 minus 1. And I can get that 1. Let's say a couple of decimals. So someone can just tell me what that is while we see what we've learned. It's really a matter of avoiding the little traps that they set. That's really the thing. When I try and do multiple transformations in one by not isolating them, I'm probably not going to do the right thing to the graph. But by following my list, which is trying to help me, I do one thing to the graph at a time. I just need to come to see it in the function, isolate that transformation. Who has a y-intercept for me? No one? No one has it? You came all this way, through the snow, the wind. Confidence. That's not good. A half square root of 2 minus 1. It's not going to be a half. It's going to be an ugly decimal number. 2 decimal places at least. 29. Negative 0.29. Let me zoom in. So what can I conclude? Is my calculation wrong? Is my graph wrong? Is anything wrong? Is all of this just wrong? Something has to change because it doesn't match up. What is happening? You need to think about it because it's very easy to do something like that. Yes, I've done it on purpose, but those things happen where it looks like things don't match up and you question everything. You need to be prepared and think, what is happening here? Is anything wrong? What needs to be adjusted?
The x-axis should be higher.
My scale was just abused so much that I couldn't rely on the shape of my graph, right? This half was this distance. And when I shifted it down, I shifted it a little distance. So it looks, I needed to shift it in order to preserve, to stay with the scale that I've used on the y-axis. This is a half. This isn't a half anymore, but it's over here somewhere. I needed to shift down by 1, and 1 is actually much bigger than I made it. It's very easy to do, and I did it on purpose. So we can go back. Can I go back? Can I get rid of my graph? That's as far as I can go. I'm going to have to erase the rest. All I need to remember that the way I draw the sideways parabola and the way it really isn't quite the same. In reality, it's much narrower than I like to draw it for convenience. So now I need to make sure I just shift down a little bit, like a nice distance. So that when I turn at a negative, or cross the y-axis, I cross at a negative number. Something like that, maybe. This is negative 1, and that negative 0.29, she said. So everything still works. I just couldn't trust my previous graph that much to see, well, how much in relation to the scale that I've used so far do I need to shift things down. But I can use the y-intercept as a safety, calculate it from the function, and it tells me where do I need to go through the y-axis. Don't rely on your graph too much, especially if it's sort of a freehand, no grid paper or anything. It's easy to be misled by a graph that isn't trying to be accurate in its scale. It's more the shape that I'm trying to preserve. Any questions on this new transformation? Where's my mouse? New transformation that we add. Now, any questions? Many times, it's not a big deal. Because if I see it in a polynomial function, I can choose to pay attention to it or not. But the square root function is not polynomial. So let me just note here that if I see it in like a cube function, for example, I have a 2, maybe a negative x plus 1 everything cubed, maybe like that. Just highlighting it. Of course, you have to simplify it to make it look like that. I can choose to do my x cubed, basic one. I like to take care of the 2, which is a vertical stretch. Then I can replace the x with a negative x, like so. And I can squeeze it in. I'll put it over here. Then I replace x with x plus 1, like so. Nothing wrong with that. So graphically what's going to happen is I'm going to stretch it vertically, I'm going to reflect it horizontally, and I'm going to shift it to the left by 1. But because of the polynomial and its properties, I don't have to. I could say, oh, let's just simplify this to be, I'll put it like that. This is negative 1 times something else, all of that cubed. That means it's negative 1 cubed, and it's x plus 1 cubed. Which means that I can put this negative 1 with my 2, and I have negative 2x plus 1 cubed. And then my transformations are still 2 to the right-hand side. The negative is now applied to the whole right-hand side. And then my replacement of x with x plus 1. So in the case of a polynomial, there are actually 2 paths of transformation that would get me to the end because of how I could simplify the original. I could have also said stretch it by a factor of 2, then flip it vertically, and then shift it. And the end result will be the same. But I can't do that unless I have a polynomial. So it's just always worth looking. What can I do to simplify my line? You can choose to rewrite it. You can choose to simplify the function first, or you can leave it the way it is in the question and just do all the transformations you see. You have options. You should know what those options are. All right. Any thoughts on that? Just know that you can, if the function is built on a basic polynomial function, then you can save yourself some trouble by simplifying it first. That is the point. Let us, in our last couple of minutes, look at problem 110. Number, well, I don't know which number actually. There are many. Let's start with an easier one. Let's maybe do 3. So I have to, they're saying in words what I need to do. I start with y equals root x as my basic function. Then they say I have to reflect it across x-axis. Then I have to shift it up by 1 unit. I have to fill in how the chain, the sequence of transformation, giving me ultimately the end result. So I start with my basic square root function. If I reflect it across the x-axis, that's just another way of saying a vertical reflection over the x-axis. so it's a vertical reflection. What is the new function in that second step? I'll start it here. Y equals. And then you say nothing. You say nothing. You have to say something. Yes.
Minus root x.
Minus root x, because my reflection was over the x-axis, so it was vertical. I have to do something to the whole right-hand side. So I know a reflection has some sort of negative in it, but the vertical and the horizontal corresponding change in the function isn't the same at all. Horizontal is a replacement, vertical is doing something to the whole right-hand side. Then lastly, I have to shift it up by 1, so my new function is this is what I'm hearing. It's not a function. Something with a square root. Plus 1. So they're just doing this backwards a little bit. They're telling me what happens to the graph, and I have to say what happened first to the function.
Please remember to click the like button if you enjoyed the video, and to subscribe if you want to be notified of more videos. Thank you.